All right, day 2 for Advent of Code is going to unlock in 3, 2, 1. But before we take a look at the problem, I'm going to copy over day 1 scaffolding into day 2. So for day 2, we've got our project set up. We've got day 2 in a cargo toml. We've got a lib.rs and we've got 2 bins. The 2 bins each use a different function. So in the case of part 1, we have day 2 process part 1. And for part 2, we have day 2 process part 2. Both of the binaries do the same thing. They both read in the input.txt file right here, and then process it and print out the result. This lets us spend our time inside of lib.rs writing both of our parts. And of course, we do have an area for testing. I'll rename this quickly, part 1 works. So now we have a nice setup to get into day 2. Day 2 seems to be some kind of rock, paper, scissors tournament. Our puzzle input is being called an encrypted strategy guide. So our input is, the first column is what our opponent's going to play, A, B, C for rock, paper, scissors. And the second column, they don't tell us, but should be X, Y, Z for rock, paper, scissors, for what we play in response to the first player. Winning every time would be suspicious, so the responses have been chosen carefully. I don't know if that means that we're supposed to not win every time or what. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score for the shape you selected, 1 for rock, 2 for paper, or 3 for scissors, plus the score for the outcome of the round, 0 if you lost, 3 if we draw, and 6 if we win. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide that they gave you. So we get our test input here, A, B, C, Y, X, Z. So in the first round, your opponent will choose rock, A, and you should choose paper, Y. This ends in a win with a score of 8. 2 because you chose paper, and 6 because you won. In the second round, B is paper, so we choose X for rock, but we lose, so we get a score of 1 because we chose rock, and 0 points for the win, or for rather the loss. The third round is a draw. We both choose scissors. So we get a score of 3 for choosing scissors and 3 for drawing. So we would get 8 for the first game, 1 for the second game, and 6 for the third game. What would your total score be if everything goes exactly according to your strategy guide? So let's get this test running first. The input here for the test is going to be these 2 things. So I think I'm going to start off with just writing an enum called move, and it will be rock, paper, scissors. I don't do this particularly often, but we can, I believe, assign integers to each of the enums in Rust. So if we coerce the enum to an integer like a U8, we would get these numbers out, which makes it really easy for us to parse these in and then convert them directly to a number, but work with the names. And a quick check to make sure that I chose the right numbers. 1 for rock, 2 for papers, 3 for scissors. I'm wondering if we can implement the partial equality trait for move to make the comparison easier for us. And then separately, I also want to come and parse each of the letters into one of the enums. So we can do something like input.lines, because that will give us each of the moves for the other people and for us for each of the rounds. I think there's a space between them. So we'll map over this with the line. And we're going to need something like an impl from string for move. I'm going to make the error just a string and this just a match. So if we match on S, then we can do A or, what is it, X is the other one? Yeah, so A and X. Okay, so we've implemented from string for move. The error type is going to be a string. We're going to match on those 3 values. And then we also need to match on the everything else. So we can do error, not a known move, dot to string. Then we can do something silly down here like line.split on space, dot collect. And we'll say that these are let moves, which is a vec of strings equals split. We need a semicolon here to finish the lines.map. Moves will have 2 values in it. I guess we could parse up here too. So split and then dot map. We'll use S for string again. S.parse move. And I'm going to bring these errors up on the right hand side so we can get a better look at them. Vec of capital S string cannot be built from result move string. That makes sense. But these are all going to succeed if we wrote this correctly. So I'll just unwrap that, which will give us string slices. And I just realized I'm not watching this. So cargo watch X check, which will do checking of the types for our program without actually building or running it. And we don't have strings here anymore because we decided to make them moves. So we have moves. And then I want to implement partial equality for moves so that we can do something like if greater than or if equal to kind of thing. So I'm using Rust Analyzer to automatically write this code out for me, or at least the scaffolding for it. And I think after thinking about it for half a second, what I actually want is to implement ORD, or more actually partial ordering, which makes more sense because it'll give us greater than and less than. So I'm going to impl partial ORD for move, let Rust Analyzer write the implementation for me. And then I think we can do something like this. And we can do this by the number order because paper beats rock, scissors beats paper, and rock beats scissors is the only kind of like one that works against the numbering here. So if the left-hand side is move scissors and the right-hand side is move rock, then the ordering is the greater than. If the left-hand side is move rock and the right-hand side is move scissors, then the ordering is less than. So the greater side is always winning. And then I think we can do something with those numbers we defined. And we didn't import ordering, I don't think. Yep, we need to import ordering. Did we not import partial ord? And then I think these are the default implementations for these other functions. I didn't remember that the return type here is supposed to be an option. So I'll put an option here. And also that we can cast values, not references. So I'll dereference those. Yada, yada. All of these need to be references. Okay. So I have made this way more complicated than it needed to be, which is probably not best for teaching you how to write Rust, but I've done it, so we're going to talk about it. Okay, so I've written the partial ORD implementation. This is probably more complicated than it needs to be, but it's the way that I chose to do it. And it's the way that I chose to do it because we get to do this code down here. So we've got process part 1, right? And we've got this input that we talked about, which in our case is AYBXCZ. So we take lines over this input and we can map over each line. Now from here, what we need to do is take each of the lines and turn it into a move or a set of moves, one for them, one for us. And we could do that in a whole bunch of different ways. The most basic of which is actually just leaving the characters in here and not implementing any traits. But if we implement from string or from str, we get to take this line here, that is a space y. We can split it on that middle part and we can map over it and we can use sparse with the type move, which is our enum, which will parse that letter into a move for us. Then I've chosen to collect this into a vec and I take the first move and I partially compare it to the second move. So if they are equal, then we have drawn. And we can add the enum as a cast to a U32. So moves, it contains the score that we have for each move. So if we draw, we get 3 points. And depending on what move it is, we get 1, 2, or 3 points. Same thing for less than. Less than means that the left side has lost. So the right side, us, have won. And then we get to do the same thing. And exactly same for greater, which means that we've lost. And then we add the move score as well. And then the same thing we did yesterday in exercise number 1, we sum all of that up and we return the result as a string. So if we run cargo test, we should get 1 passing test and 1 failing test. 1 failing test because we're still running part 2, which I'm going to ignore for a second. So now that we've used the ignore attribute macro on this test, we can scroll up and see that we have 1 passing test and 1 ignored test. So this is a reasonably complicated way to do it. Why did I do it like this? We've got the enum move here, right? And we've got 3 variants, rock, paper, and scissors. I've chosen to give each of those a number. Now what this means is that if we cast this enum to a U8, or really any integer, like we're doing right here, that gives us a default ordering for paper beating rock and scissors beating paper. What it doesn't give us is rock beating scissors because these numbers don't match up like that. So if we implement partial equality, which means that rock is going to be 1, paper is 2, and scissors 3, which means that if we have scissors and scissors, they'll mark as equals. And then I've also derived copy and clone, which are 2 additional traits. We can write an implementation of a partial ordering for move. This partial ordering requires that we implement a function partial CMP or partial compare. It gives us a value on the left that's a reference to some move value, so it's either rock, paper, or scissors, and a value on the right, which is either rock, paper, or scissors. It requires us to return an option ordering. So why partial ord? Partial ord because we have rock, paper, and scissors, but it's circular. There is no max value. You don't have one move that beats all of the others. So if we look at the ord trait, which is the total ordering, we would have to implement comparison, max, min, and clamp. And we don't have a min value and we don't have a max value. We have a loop. So that's why I chose to implement partial ordering. Partial ordering is a partial comparison, and it's also got less than, greater than, less than or equals, and greater than or equals, which correspond to all of the mathematical operations that you are used to. So equals, greater than, less than equals, greater than equals, whatever. Each of these four functions has a default implementation for the trait, so we don't actually need to touch them. And partial compare is the function that we need to implement. So we can handle the special case of scissors and rock right off the bat using an if expression. So we're doing if left-hand side is scissors and right-hand side is rock, then we'll return a greater ordering. And we have to wrap that in sum because it could possibly be incomparable. And then we do the same thing with rock on the left side and scissors on the right. We return ordering less. So this takes care of our special loop around case, whereas everything else can be handled if we cast our enum to a U8. So if we take the value on the left and we use it as a U8 and we compare that to the value on the right and we use a U8, then what we're doing is comparing 1 to 2 and 2 to 3. But we've implemented a special case for 3 to 1. And what this lets us do is just parse the move out and then compare them together. Again, it's a little convoluted. We do have to implement two different traits. So if you're not used to seeing traits, that might be a little bit confusing. But overall, we can reduce the code for process part 1 to move on the left compared with move on the right. And then whether it's a draw, they win or we win, plus the score of the move that we gave. So let's go grab our puzzle input, all of this, drop this into input.txt so we can run the program with 13,009. We can put our answer in here and hopefully we've got 1 gold star. Huzzah. Okay, so for part 2, the elf finishes helping with the tent and sneaks back over to you and finishes what they were saying. Anyway, the second column says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. The total score is still calculated in the same way, but now you need to figure out what shape to choose so the round ends as indicated. The example now goes like this. So our test input here is A, Y, B, X, C, Z. So in the first round, opponent chooses A, which is rock. You need the round to end in a draw. So you also choose rock. This gives you a score of 1 plus 3 equals 4. In the second round, your opponent will choose paper, B, and you choose rock, so you lose, with a score of 1 plus 0 equals 1. In the third round, you will defeat your opponent's scissors with rock for a score of 1 plus 6 equals 7. Okay, so let's take this value and drop it in for process part 2. And I can run a cargo test, and we can see that the part 1 is passing, and the part 2 is getting ignored. So let's get rid of the ignore here on the test. And how does this change our logic? So first of all, our from string implementation would need to change, right? Because A and B and C are now moves, but X, Y, and Z are what we need to do. So I think we would need to go, if we go from an enum to a number, and then we did something like increment the number and then modded it with, say, 3, we would be able to get back into the enum to pick which value we should be choosing. But I don't think there's a way to go from the number to the enum without writing a custom function in Rust. So we'll have to write that if we choose to go that way. So really this whole partial ord goes out the window. We don't need it anymore because we just won't be using it. The from string implementation needs to change. So we need to get rid of X, Y, and Z here. So we can still do for process part 2, input.lines, map over it, moves, split, map. But in this case, we can't do the map here. So we're going to split and collect into moves. Opponent move is going to be moves 0.parse move.unwrap because that should never fail. And then we need to match on moves 1 for what we need to do, which is either going to be X, Y, or Z. We can get rid of this whole match right here. And what we end up with is the opponent's move and whether we're supposed to win or not. X means we need to lose. Y needs to end in a draw. So Y is the easiest, right? The draw is 3 points plus the opponent move as a U32. So basically the same thing that we have up here for the same logic, this one in particular. So let's do a cargo test because I'm getting some errors here and I'm not entirely sure why yet. Match arms has incompatible types. Yes, that makes sense. Let's put a 0 here and a 0 here. Oh, right. Okay, I didn't change this. So line.split whatever. This is going to be a vec of, I think, string slices, not moves, because we're doing the parsing later now. And then I haven't accounted for all of the potential errors that could happen. So we'll panic here if it's anything we don't expect. Unexpected, I don't know what to call this, move, response. We'll go with response for that because we're matching on moves 1, which is a string. So it'll be X, Y, or Z, but it could also be literally any character because Rust doesn't know that we're passing in only X, Y, Z at runtime. So in that case, we'll panic and make it known, yada, yada. Okay, so we're left with 4. So we need 12. We need to implement X and Z. Z means we need to win and X means we need to lose. So I think doing this manually is going to be simplest. And we can just match on the opponent move. So if they play rock, we need to play scissors. If they play paper, we need to play rock. If they play scissors, we need to play paper. So let our move equals this. And then we do what we lose. So it's 0 plus our move as a U32. And then it's going to be the same thing for Z. So nothing fancy this time. I think I spent our complexity budget in the first problem or the first part. So I wanted to make this a little bit more straightforward. So our move now needs to win. So this now needs to be paper. This now needs to be scissors. And this now needs to be rock. And now if we run our test, it's still failing because I did something wrong. Because I'm not adding 6 when we win. So cargo test, our tests are passing. In this case, I didn't use any of the fancy stuff that we had other than the ID of the enum variant. So let's do cargo run bin part 2 with our input, which is 10,398. Let's go down to our answer and see if we did it correctly. And we did. So that's part 2. So if we scroll down here, we have 2 stars for part 1 and 2 stars for part 2. So I'll commit that for now and push it up. And if I revisit part 1, I think that this is fine, actually. It does feel a little bit more complicated. I'm enabling s.parse with the from string implementation. I'm enabling partial comparison with the partial ordering trait. I think that implementing these traits is the right way to go. We could, of course, take it from here and not parse these moves. And then here, instead of doing this match, we would have to rewrite the comparison code, which wouldn't be too bad. There's only, 6 variations to write. So we would have to write it out manually. And basically, we could do that. That would look something like this. Of course, this is all going to return the wrong value. So let me just throw in a number here so that Rust Analyzer is happy. But we could do this the whole way. So basically, if they're the same, this could all be for, let's say, whether we've won or not. So what do we have here? 3, 6, 9 options, 3 of which are draws. So this is going to be a draw, and a draw, and then paper beats rock. Oh, no, I did that wrong. Of course I did. So this is a draw. Paper beats rock, so we win. Rock beats scissors, so we lose. Paper beats rock, so we lose. Paper and paper are the same, so we tie. Paper and scissors, scissors wins. Scissors and rock, rock wins. Scissors and paper, scissors wins. Scissors and scissors is a draw. So if I save this and we run cargo test, we're getting 9 instead of 15 here because we still need to add moves 1 as a U32, which I have messed up. So let's do moves 1 as U32 beforehand. and then we do the match as the addition, and this should give us the right answer. So this is a passing test here. So if you felt like the approach I took for part 1 was too complicated, you're not ready for traits yet, it's totally fine. You don't need to use them. You could do this entirely, replacing each of these enum variants with a string. It's totally fine. You don't need to use this parse even. And you could just do one giant match and insert the scores for whether the right-hand side has 1 or not into each of those matches. This looks a little bit more funky, but I like having the logic in the trait instead of doing it manually. But that's the only difference. So you don't have to use this trait. You don't have to do this partial ORed implementation. If that doesn't make sense to you, it's totally fine. Take the move, take the variants, take the values for each of the variants. And then instead of matching on the partial comparison, you can match on just every individual set. So this is the difference between having to match on every individual set of values and being able to match on an enum that tells us which side won. So that's day 2. I'm going to go edit this video. I hope you enjoyed this, and I'll catch you tomorrow for day 3. Feel free to ask some questions because I know this trait stuff can feel complicated, especially for people new to Rust. So have a great day.